Good, excellent. Alrighty, so this group is also involved in an informal manner in the standardization process. The Schema working group is led by me and Juan Sequeda of data.world. And basically, we try to be the informal counterpart to the real standardization group, WG3, in the sense that we try to give feedback, try to respond, try to sort of act as a forum that independently thinks about issues. Petra actually already listed a lot of people. There's actually many more people passively involved. I think on Basecamp and Slack, we work mostly on Slack at the moment. Combined, there's like 75 people involved, quite a few from industry and quite a few from academia. And the inspiration, most of who are here know this already, but those who were not earlier aware of this came from earlier work on G-Core, which tried to formulate an academic core language that could serve as a starting point, as a core language for GQL, actually, for the pattern matching language in particular. And so given that success, people thought it might be interesting to do a continuation of this for the schema definition language. And that's basically what this group is focusing on. And so the history, again, most of you know this already, so I'll quickly go over this, is that it basically started after GCure in 2018, especially the W3C workshop in March 2019 was very important, where basically we sort of started this and also got our, let's say, our main objectives, where people said, well, what you should try to do is give formal semantics of this, try to give a simple definition that everybody agrees with, etc., etc. And so that started this. In the meantime, we've actually become officially affiliated with the WG3 group in the sense that because there's now a legal framework that allows us to exchange documents and also to actually have members of the informal working group present at the WG3 meetings to follow what's going on there and to allow us to sort of respond to what's going there as quickly as possible. Our work turned out to be so comprehensive that in the meantime, this got, let me have a pointer here, separated into several subgroups. So we have actually 4 subgroups at the moment, with here the basic, this is a bit slow, okay, the basic group focusing on the basic construct. So what does the schema look like? What are the basic constructs that you want, and what is their semantics? We have a separate group that focuses on constraints, like key constraints and cardinality constraints in particular, because those tend to be the most essential. And that's led by George Fletcher from the Eindhoven University of Technology. Then there is a separate group that focuses on the type system for properties in the property graph data model, because it turned out that for property graphs, this fact that you have 2 layers of the graph layer and then sort of at a smaller level, the values that are attached with the nodes and edges, people tend to actually push a lot of information in there if they don't want to see this in the topology. So it becomes very interesting to see what type of typing mechanism you want to have there and how rich it should be and what it should be able to do, etc. And relatively recently, a separate group was founded for null values. By the way, the property type group is led by Joshua Chinavere of Uber. And the last group quite recently added is led by Angela Bonifati of the University of Lyon and deals with null values, which turned out to be a very interesting and big topic, also in the context of property graphs, because we might have undefined properties, because we have to be integrated with SQL, for example, where we already have null values. And so that raises the question, is that the same kind of thing, a missing property and a null value in a column, etc., etc. And this has recently started and is in some sense still in the stage of just analyzing what is out there and what people have been saying about null values in the past, which most of you probably know is actually quite a lot. And it's actually a wide field and a very big discussion. And so we're very happy to sort of open that up again, almost again for property graphs. And so that's ongoing. I'm trying to go to yes. So what are the things that we've been talking about? So I'll rattle off a long list of issues that we've been looking at. I will not try to explain them, but just so you have an idea what we've been talking about. So I've been, wait, I think I went, yes, sorry, I went to one slide too far. So we had a discussion about property types, what they should do. So there's sort of a common understanding that at least there should be collection types, records, sort of the normal types that you expect, for example, from traditionally in object-oriented databases, for example. There has been a discussion on meta properties, for which we actually have use cases that at the top level, and maybe even nested inside values, you might have meta properties that give you things like time or provenance of data. There's been quite a big discussion about key constraints, which has been one of the most productive ones, actually, where we discussed simple key constraints that simply say that certain properties form a key or combinations of properties, but also about more complex key constraints where actually you might have a graph pattern that identifies a set of nodes or a set of edges, and another graph pattern that then identifies what the keys of those elements actually consist of. And in fact, we had an accepted paper at Sigmod about this, about sort of the basic concepts that we developed there. And recently we submitted also the VLDB, which actually I'm happy to say today we got a positive feedback from. So we have to do a revision, but basically it's an accepted paper. And that is also being continued at the moment concerning cardinality constraints, which in some sense are a generalization of key constraints, if you will, where we've been discussing simple cardinality constraints, just the ones that correspond to having one-to-one and many-to-many and one-to-many relationships, but also more complex cardinality constraints that, you know, change the upper bounds to arbitrary numbers and also have graph patterns that allow you to select the nodes and edges for which you want to state this, in fact. Other discussions that have quite well advanced. By the way, the bubbles that you see here indicate which groups have been involved in those discussions. So not all issues are discussed by all groups, of course. That was the whole point of splitting this up. We had some discussions on schema flexibility, because property graphs in some sense have a specific use case that's of course different from, let's say, relational databases, where we want, in this case, additional flexibility. So what does that mean for the typing system? What does that mean for the schema language? And so there are some sort of fairly robust ideas about certain things that you should be able to do in the property schemas to allow for that type of flexibility, like having optional properties, for example, or optional fields in records, which we more or less see as the same thing, or that we identify certain types as open in the sense that you can have a record that must be of that record type, but maybe it might also be a subtype that has more fields or specializes certain fields, for example. We had discussions about whether types can be combined in the sense of the entity relationship model, which is in some sense guiding us to some extent, where you can have overlapping subtypes. And the question was, do we also want that in our schemas if we want to be similar? And the answer actually is to a large extent no, to keep it simpler. And so that means that types by default are assumed not to be overlapping and subtypes are assumed not to be overlapping, but that we would have a construct that allows the user to explicitly say that in some cases they actually can overlap, and then allow users and graphs that conform to the schema to belong to arbitrary combinations or to combinations that are indicated as allowed in the schema. So also for that, we're actually writing a paper at the moment, but that's still in preparation. That hasn't been submitted yet. Then discussions that have sort of recently started and about, for which there's a wide variety of opinions still actually, on, for example, do we want both nominalized and structural typing? Structural typing is usually a more natural setting in a semi-structured setting, for example, like we sometimes also want to be. But SQL to a large extent has nominalized typing, not completely, and we need to integrate with SQL. So probably we also need that here. And so that's a big challenge, how to do that in an elegant and effective fashion here. We've discussed union types, both the tagged union types and untagged union types, if that rings a bell with people. Both of them seem useful. Untagged union types, for example, can be quite powerful, but sometimes quite complex. Untagged unions are a bit simpler to implement, but don't always give you the power that you actually need. For example, specifically, and that's a big issue for us, if you want to generate a schema for a graph that actually doesn't have a schema at this point in time, which is a use case we expect to encounter a lot. And then finally, the null values, which are already discussed. So also there's a big discussion going on. Do we actually need null values? And if we need them, how is it going to work? Is it going to work like SQL, which of course has received a lot of criticism in the past? Do we try to avoid the problems there, or at least the problems that people think are problems? Also, and I already mentioned this, the derivation of a schema. That's a big issue because there's different reasons why you might be doing this. And so there might be different algorithms that are appropriate for that. And so identifying actually even just what people typically are trying to do if they try to derive a schema for a graph that does not have a schema. And if you want to do so, what requirements does that pose for the schema language that we're trying to define? That's all very much still open for discussion. And then finally, the issue, of course, of type inferencing. If we have a schema present and if you have a query, of course, you can try to type the query. You can try to check if the query makes sense or not. You can try to generate the output type of the query. And also that is a discussion that actually has just been started. So you can see there's actually still quite a lot of discussions still going on. And so there is a lot of work still to be done, and a lot of discussions which are still really quite open and could go in lots of different directions. And that's what I wanted to tell you about today. So that concludes my presentation.
Thanks, Jan. So that's very interesting. Like schema is the basis of many things and many discussions. Are there questions already in this meeting? Because we are on time. Hey. Can I ask you what the VLDB paper is about? So how does it continue on PG keys?
Oh, so it actually talks already about cardinality constraints and about evaluation complexity of cardinality constraints. So specifically about, let's say, if you're mining in a graph that doesn't have key constraints and you want to mine for certain key constraints, how do you do this efficiently? But also just checking them. So just you have a graph and you have a certain cardinality constraint. How is it possible to, as efficiently as possible, to check whether the constraint is satisfied? Because this is close to counting queries, but in some sense, you're not interested in the result of the count. You're just interested whether the count is below a certain number or above a certain number. And that changes a little bit the complexity considerations and the type of algorithms that you can be using for that. And so especially the people who are interested in the theoretical complexity of that have done quite a thorough analysis of this, and indeed have implemented this to some extent. So that's what that was about.
In the meantime, has anybody else thought of a question?
Yeah. Hi, Peter. This is Satanas Kiraku. Do you hear me?
Yes.
Yeah. So a quick question on what we shall expect next and time-wise regarding property graph schema.
Well, I think I can refer to the talk of Keith there, and also to Stefan's talk, who will be, because we're just the informal group in some sense. We're just, academics and some and industrial partners who are talking sort of as volunteers with each other about this, but the real standardization happens in the WGT group, and so you can ask them about the timeline.
Okay, thank you.
Okay, well, in the interest of time, then let me then thank Jan, of course, and then everybody in the group.